गुड मॉर्निंग विद्यार्थियों, एमएस पटेल ई लर्निंग वीडियो क्लास में आप सभी का स्वागत है। इस वीडियो लेक्चर में हम मैग्नेटिक फील्ड इंटेंसिटी ड्यू टू अ करंट कैरिंग वायर ऑफ फाइनाइट लेंथ डिस्कस करेंगे। दिस इज ए पार्ट ऑफ मैग्नेटिज्म एंड स्पेशली एप्लीकेशंस ऑफ बायोट सावर्ट्स लॉ। तो यहाँ पर हम लोग बायोट सावर्ट्स नियम के अनुप्रयोगों को डिस्कस करेंगे। सो फर्स्टली हमको यहाँ पर डिस्कस करना है मैग्नेटिक फील्ड इंटेंसिटी ड्यू टू ए करंट कैरिंग वायर ऑफ फाइनाइट लेंथ। सपोज वी हैव अ वायर which has a current of I ampere, and from this wire at a distance small r at a point P, we have to find out magnetic field intensity. So here at a distance from point O, suppose this is the point just opposite to point P on the wire, we take a distance x, and from this distance its elementary part is taken delta x. ये जो करंट कैरिंग सेगमेंट लिया हमने वो डेल्टा x है, और यहाँ डेल्टा x इस x डिस्टेंस से पॉइंट P की डिस्टेंस कैपिटल R ले ली। ये now take this angle. Suppose if this angle is theta, then if this angle is 180 minus theta. This is the line segment delta x. This is the wire. It's one of the end is A and other end is B. When we start from A, suppose this angle is theta 1, and when we reaches to point B taking this delta x along this wire, suppose the final angle in the same direction, that is 180 minus theta 2, so this angle will be theta 2. Angle is to be measured only in one direction, that is in this direction. So that is, this angle is 180 minus theta and the inner angle is theta 2. This is theta 1. So now applying Biot Savart's लॉ। अब हम बायोट सावर्ट नियम को अप्लाई करें फॉर दिस लाइन सेगमेंट, करंट कैरिंग लाइन सेगमेंट। हियर सपोज मैग्नेटिक फील्ड इंटेंसिटी एलिमेंट्री पार्ट इज dB is equal to mu 0 upon 4 pi I dx sin, and taking this angle, we have to take this angle 180 minus theta। ये बायोट सावर्ट नियम में जो लाइन सेगमेंट को पॉइंट P से ज्वाइन करने वाली जो लाइन है वो कैपिटल R है, और वो I की डायरेक्शन से करंट के साथ कितना 180 माइनस थीटा एंगल। सो 180 माइनस थीटा डिवाइडेड बाई कैपिटल R स्क्वायर, that will be the differential equation expressing Biot Savart's law. So what we have now, dB is equal to mu 0 upon 4 pi I dx. This is sin theta, sin 180 minus theta is sin theta divided by R square. Take this equation 1. Now this distance this distance is r, and this is known. This is known distance. This x distance varies. This r varies. So we have to express x and r both in terms of small r. In order to change this expression in a single variable so that we can integrate it. Okay? ये आपको इस डिफरेंशियल इक्वेशन को सिंगल वेरिएबल में चेंज करना है. x और capital R, x and capital R, these are the two variables, but the small r distance is fixed. So small x and capital R both are to be expressed in terms of small r. So what we have here, x divided by small r is equal to cot theta. So x is equal to r cot theta. Now differentiating this equation, we have dx equal to r into minus cosec square theta d theta. Suppose this is equation number 2, and also we have capital R divided by small r is equal to capital R divided by small r is equal to cosec theta, या capital R equal to small r into cosec theta. This is equation number 3. Now taking these three, equation 1, 2 and 3. So now from equations 1, 2 and 3, what we have from equations 1, 2 and 3, we have dB is equal to mu 0 upon 4 pi I. Dx is replaced by small r into minus cosec square theta d theta, and this sin theta is intact, divided by capital R square, which is equal to r square cosec square theta. So now we have only one variable in this expression. Theta is variable, whereas small r is fixed. So we have converted the entire equation into a single variable. So here cosec square theta cancelled out. One of small r cancels this small r. So we have dB is equal to mu 0 upon 4 pi I minus sin theta d theta divided by small r. So guys, very interesting. This entire so difficult expression or derivation has now changed to simple one. Okay? What would happen? Now integrate it. So integration dB is equal to mu 0 upon 4 pi I upon r integration minus sin theta d theta. What is the limit of theta? Theta starts from theta 1 to 180 minus theta 2. Starting from here, so upper limit is 180 minus theta 2 and the lower limit is theta 1. Here यहाँ ये इंटीग्रेशन माइनस साइन थीटा डी थीटा आपको लेना है. Starting limit is 180 minus theta 2, so lower limit is 180 minus theta 2 and the upper limit is theta 1. So what we have, b equal to mu 0 upon 4 pi I upon r, integration minus sin theta, it is equal to cos theta, lower limit is 180 minus theta 2 and upper limit is theta 1. So we have here b equal to mu 0 upon 4 pi I upon r, putting upper limit cos theta 1 minus cos 180 minus theta 2. So here cos 180 minus theta 2 equal to minus cos theta 2, so minus minus plus. So finally we have b equal to mu 0 upon 4 pi I upon r cos theta 1 plus cos theta 2 in it. So here this is the final expression for the magnetic field intensity due to a current carrying wire of finite length, where theta 1 and theta 2 are the end angles subtended by the wire on point P. These are the two adjacent angles, theta 1 and theta 2. These are the base angles on point P formed by the wire of finite length. So that is the magnetic field intensity. So next we can take a case. Now case number 1 here, magnetic field intensity due to current carrying wire of infinite length. We can proceed with taking the formula previously derived. B equal to mu 0 upon 4 pi I upon r inside bracket cos theta 1 plus cos theta 2. So case 1, when this wire is of infinite length, we have B is equal to mu 0 upon 4 pi I upon r cos theta 1 plus cos theta 2. These are the angles. This angle is theta 1, this angle is theta 2, this distance is r, this is the point P, this. Now when this wire becomes of infinite length, so that angle theta 1, now this A point reaches to infinite, so theta 1 angle reduces to 0, so this angle will be 0, and also when B point reaches to infinite, this theta 2 angle reduces to 0 degree. So these both angles for the infinite length will be 0 degree. So here we have mu B equal to mu 0 upon 4 pi I upon r into cos 0 plus cos 0. So that is 1 plus 1. So it is equal to mu 0 upon 4 pi I upon r, 1 plus 1, this 2 cancels this 4, so we have mu 0 upon 2 pi I upon r. So this is the expression, this is the formula for magnetic field intensity at a point P from a current carrying wire at a distance r of infinite length. This wire being of infinite length, so that is infinite length का होगा, तो that theta tends to 0, theta 1, theta 2 tends to 0. So जब ये वायर इनफाइनाइट लेंथ का होगा तो मैग्नेटिक फील्ड इंटेंसिटी हो जाएगी म्यू 0 अपॉन 2 पाई आई अपॉन आर। Case 2 follows as magnetic field intensity near to one end of current carrying wire of finite length. Now we have to find out magnetic field intensity due to a current carrying wire of infinite length, but we have to find out near to its one end. Means one of its ends is known, but the other end goes to infinite. So what would happen here? We have such a case. This end goes to infinite. This end is known. Suppose it is the end A dash, or suppose it is A. This is known. This end is that goes to infinite. That is, we have to find out the magnetic field intensity at point P. This is point P, and this distance is now small r. So what is our case? Now this angle, that since it meets at infinite, so this theta 1 tends to 0, and this angle is theta 2, and this is equal to what? This is equal to 90 degree. This is equal to 90 degree. So that will be the change. Okay? When you take such a wire or current carrying wire of infinite length, and you are standing near to its one of end, and at a distance small r from this end, you have to find out the magnetic field intensity. अब आप बहुत लंबे इनफाइनाइट लेंथ के वायर के एक एंड के पास खड़े हैं स्मॉल आर डिस्टेंस पर, और उस पॉइंट पर आपको मैग्नेटिक फील्ड इंटेंसिटी ज्ञात करना है, निकालना है। तो क्या हो गया यहाँ पर? दैट इज थीटा 1 इज इक्वल टू 0 एंड थीटा 2 इज इक्वल टू 90 degree. So applying these two conditions to the formula initially derived, B equal to mu 0 upon 4 pi I upon R cos of theta 1 plus cos of theta 2. This is the most general formula. इस फॉर्मूले में हम ये थीटा 1 इक्वल टू 0 और थीटा 2 इक्वल टू 90 अप्लाई कर देते हैं। सो B इक्वल टू म्यू 0 अपॉन 4 पाई I अपॉन R cos 0 और प्लस cos 90 degree. Cos 90 degree is 0 and cos 0 is 1. So that comes out mu 0 upon 4 pi I upon R into 1. So finally we have B equal to mu 0 upon 4 pi I upon R. That will be the magnetic field intensity at one of the end of current carrying wire of finite length. Now moving to next derivation, we are going through the topic applications of Biot Savart's law. So in this regard, next derivation, it is follows as magnetic field intensity at a point on the axis of current carrying loop of radius A. Suppose we have a loop of radius small a, its radius is small a, and on its axis, this is its axis, at a distance X from its center. This is the center of this current carrying loop. Suppose current in this loop is in this direction, I. This loop is not in the plane of whiteboard. ये जो लूप है ये व्हाइट बोर्ड के प्लेन में नहीं है, बट इट इज ऑफ दिस वे. इट्स प्लेन इज, ये जो लूप का प्लेन है वो व्हाइट बोर्ड के प्लेन के परपेंडिकुलर है इन दिस वे. सो दिस इज रादर अ 3D पिक्चर. ये 3D पिक्चर है. यहां पर हम ये DL लाइन सेगमेंट, करंट कैरिंग सेगमेंट लेते हैं. दिस इज द पॉइंट वेयर वी हैव टू फाइंड आउट द मैग्नेटिक फील्ड इंटेंसिटी. दिस डिस्टेंस इज टेकन, सपोज स्मॉल r, ये स्मॉल r डिस्टेंस ले लिया. नाउ दिस लाइन ये मेक्स एन एंगल now 90 degree with the circumference of this loop, because loop is of this way, इस तरह से, और this is the line. So here this line is at an angle 90 degree to this loop, because loop is of this case, इस तरह से है ये. तो इसके इस लाइन और इस लूप के इस लाइन सेगमेंट के बीच बनने वाला एंगल कितना होगा? 90. सो हियर थीटा इज इक्वल टू 90 डिग्री इन बायो सावर्ट्स लॉ. नाउ अप्लाइंग, दिस इज द डायरेक्शन ऑफ करंट. लूप गोज इन दिस वे. दिस इज द डायरेक्शन ऑफ करंट इन अपर पार्ट. This is the direction of current. Fingers indicate or towards point P. This is the point P. So in this way, so the push direction is perpendicular to this line, that is this. So suppose that field is del dB dash. Here dB dash हो गया. We take this angle as theta. This angle is 90 degree. So it is 90 minus theta. This is 90 minus theta. Now we take this direction perpendicular to axis. So now this angle will be theta. Okay? So here this is dB dash cos theta. It's a component. Its component, dV dash का component इस direction में. This is 90 minus theta. This angle will be theta. So in this direction, this is dV dash sin theta. These are the two components of magnetic field intensity produced by DL, current carrying segment at point P. So dB dash के दो कंपोनेंट्स हो गए, dB dash sin theta and dB dash cos theta. Now due to symmetry of loop along the axis, this is the loop, this is the axis. When you take DL in upper part, dB dash cos theta is upward. When you take DL downward at the lowest point, the dB dash cos theta will be just below, downward. So, or when DL is taken here, dB dash cos theta will be in this direction, and when you take DL here, dB dash cos theta will be in this direction. So, this dB dash cos theta will remain directed at point P in this way. So, this is cancelled out due to symmetry of the wire. So, due to symmetry symmetry of loop about its axis, component dv dash cos theta cancelled out. So this component will get cancelled out. Take dv dash. Remaining part is dv dash sine theta. So remaining part, remaining magnetic field component is dv dash sine theta. So this dv dash sine theta can be taken as db. So db is equal to dv dash sine theta. Now if we integrate dv, then we will find the total magnetic field at this point P. So integrating this dv is equal to integration dv dash sine theta. Here this is equal to B. Now dv dash according to Biot Savart's law, Biot Savart law के अनुसार dv dash कितना होगा? It is equal to mu 0 upon 4 pi I dl sine. Now for Biot Savart law, theta equal to this angle is equal to 90 degree with this line segment. इस लाइन सेगमेंट के साथ ये जो इस लाइन सेगमेंट के साथ जो ये एंगल बनेगा वो थीटा अगर हम इसमें हम लोगों ने थीटा ले लिया, इस एंगल को आप कुछ और थीटा डैश कह देते हैं, तो साइन थीटा डैश इनटू साइन थीटा डिवाइडेड बाय दिस r square. This will be the expression. This theta dash is 90 because dl segment, dl is in this way and r is this. So angle between these, it is equal to 90 degree. So here we have b equal to integration mu 0 upon 4 pi I dl sin theta dash. Sin theta dash is 90 degree into sin theta divided by r square. Okay? So sin 90 equal to 1. In this case theta is not going to change, theta change नहीं होगा, r is not going to change, r भी change नहीं होगा. ठीक है, तो क्या करना है, that is इन सब को आप बाहर ले सकते हैं. So b equal to mu 0 upon 4 pi, I is not going to change, theta is not going to change. Okay? This is a small r square that will also not change, and integration dl. So guys, we have here b equal to mu 0 upon 4 pi I sin theta, sin 90 equal to 1 divided by r square integration dl. So here b equal to mu 0 upon 4 pi I into a divided by sin theta equal to a upon r. So sin theta equal to a upon r into r square r cube. Integration dl is 2 pi a. So finally this 2 pi cancels 4 pi. So here we have 2, b equal to mu 0 upon 2 I into a square, that is, and here r, value of r, here r square equal to a square plus x square by Pythagoras theorem. So we have r equal to a square plus x square raised to power 1 by 2. Here replacing this r, a square plus x square raised to power half whole raised to power 3. So finally we have b equal to mu 0 upon 2 I into a square divided by a square plus x square raised to power 3 by 2. So दोस्तों ये आपको इस तरह से मैग्नेटिक फील्ड इंटेंसिटी ड्यू टू अ करंट कैरिंग लूप ऑफ रेडियस a आपको मिला, जहां पर x जो डिस्टेंस है वो लूप के केंद्र से उस बिंदु तक की डिस्टेंस है जिस पॉइंट पर आपको मैग्नेटिक फील्ड इंटेंसिटी डिटरमाइन करना है, मैग्नेटिक फील्ड इंटेंसिटी निकालना है. ठीक, ओके गाइस. सो नाउ अब हम डिस्कस करेंगे इस फॉर्मूला जो ये डेरिवेशन किया इसके कुछ केसेस को लेकर के चले. फर्स्ट केस 1 इज मैग्नेटिक फील्ड एट द सेंटर ऑफ लूप. अगर लूप के सेंटर पर ही आपको मैग्नेटिक फील्ड इंटेंसिटी को फाइंड करना है, तो क्या करेंगे, x जो डिस्टेंस थी वो लूप के सेंटर से पॉइंट P तक की डिस्टेंस थी. When P point reaches at the center of the loop, this x becomes 0. So for this x equal to 0 in what b equal to mu 0 upon 2 I a square divided by a square plus x square raised to power 3 by 2. So what we have, b equal to mu 0 upon 2 I a square divided by a square plus 0 square, this x is replaced by 0 raised to power 3 by 2. So finally we have mu 0 upon 2 I a square divided by a square raised to power 3 by 2. So this 2 cancels this 2. So here we have a cube. So the expression becomes mu 0 upon 2 I upon a, where a is the radius of loop. So this will be the magnetic field intensity at the center of the loop having a current I, and the radius of the loop is small a. Next case which we are going to discuss, that is magnetic field intensity due to a coil of number of turns capital N. So in case if you take the point on the axis of coil, this is coil having number of turns capital N, and if you take the point at a distance x from the center of the coil at this point, so what would happen? Due to a single loop we have b equal to mu 0 upon 2 I a square divided by a square plus x square raised to power 3 by 2. This is the radius ax. ये एक्सप्रेशन था ड्यू टू ए सिंगल लूप की वजह से ये. और इन केस इफ देयर आर कैपिटल N टर्न्स, देन दिस फील्ड गेट strengthened by N times. So what will be the magnetic field intensity? B equal to mu 0 upon 2 and I a square divided by a square plus x square raised to power 3 by 2. This is due to coil. coil की वजह से ये जो फील्ड होगा वो इस फील्ड का n टाइम्स हो जाएगा. मीन्स इन केस अगर हम इसको b डैश कहें तो b इक्वल टू n टाइम्स b डैश. So that will be the magnetic field intensity due to coil of number of turns capital N. In case if we take magnetic field intensity at the center of the coil, magnetic field intensity at the center of coil, coil के सेंटर पर क्या होगा? For this x equal to 0. So this formula changes to mu 0 upon 2 NIA square, x equal to 0. So x, substituting x equal to 0, we have here a cube. So that is equal to mu 0 upon 2 Ni upon A. That will be the field when you take, so here you can write in box, be equal to mu 0 upon 2 Ni upon A. That is the magnetic field intensity due to a coil at its center. Okay guys.